137 meters long, 23 meters wide, 3 full stories rising above a shingled deck, numbers that read less like myth and more like an architectural brief. Imagine that line on a page, a drawing in ink and timber, a demand for workmanship on a scale no one around Noah had ever attempted. This is the starting point for our reconstruction. Noah's Ark as an engineered project, the work of forgotten builders answering a divine blueprint. What follows is not a claim of archaeological certainty, but a careful, reverent reconstruction. Plausible techniques, ancient practices, and the sensible choices those builders might have made under God's command. We will move step by step through site selection, timber work, keel and framing, sealing with bitumen, the complex interior logistics of 3 decks and many compartments, and finally the door that was both a practical necessity and a theological hinge, remembering always that the Lord shut the door. If you find this kind of biblical reconstruction meaningful, please subscribe and check the sidebar for a companion video that follows the ark after it rests on Ararat. When God spoke, the instructions were precise: length, breadth, and height, a material named cypress or a similarly durable timber, 3 stories and rooms or compartments across those decks, put a door in its side, and make a window acute it from above. The text supplies the outline, the dimensions, and a handful of technical terms like bitumen. What the text does not supply are the craft details: how to turn raw forest into a 137-meter hull, how to keep such a structure watertight, and how to turn an immense hold into a functioning habitat for people and animals for months at sea. Those gaps are where sensible engineering meets faith. Site selection: the forgotten builders first face the ground itself. Genesis hints at a world already saturated with moisture. The ancient description of a mist rising from the earth reminds us that this was no dry, rocky plateau, but a landscape prone to seepage and soft soils. Building a vessel this large required firm footing while assembling heavy timbers and shaping a continuous backbone. Likely steps included choosing higher, better draining ground near sufficient timber supplies, clearing and leveling using hand tools, and compacting the site to support staging areas and temporary ramps. Picture the site, the air heavy with mist, boots sinking into damp soil, men and women tamping earth with logs and stone mallets. They dug shallow trenches or diversion channels to carry seasonal runoff away from the building yard. Where the ground was softer, they layered cobbles and packed clay, creating a broad, stable platform. Earth ramps would be piled alongside the emerging hull, ramps that allowed large beams and keel sections to be hauled into position and then braced while joints were fastened. These are likely practical measures. Later builders in many cultures used the same basic methods when they lacked metal-heavy lifting gear. Then, the forest work. The ark's timber must have come from mature trees. Cypress is named in some traditions, and the biblical text indicates a durable, rot-resistant wood. Felling such trees with stone and bronze axes and adzes was arduous but routine for ancient loggers. Teams would select straight trunk specimens and limb and square them at forest camps. To keep rot from setting in, logs might be stored dry, stacked and raised off wet ground, or worked promptly after felling. The smell of resin and fresh-cut sap would have accompanied the work, an almost tangible sign of the transformation from living tree to structural element. Transporting massive trunks to the building site without wheeled tractors required ingenuity. The most probable methods draw on technologies that are well attested across the ancient Near East and beyond. Rollers, round logs used as temporary bearings laid under sledges, greased roadways, groups of oxen or men pulling with ropes and levers, and, where necessary, simple sledges sliding on wet clay or wooden planks. Stones or small boulders placed as fulcrums and simple levers multiplied human strength. Staging yards close to the construction site allowed the builders to process timbers, square beams, and lay out long members for joining. A central technical problem was unavoidable. There is no tree 137 meters long. The ark's specified length demands joining many shorter timbers into continuous, load-bearing beams. Ancient shipwrights and carpenters solved similar problems with carefully engineered joints. In reconstructing the ark's backbone, scholars plausibly imagine long longitudinal members assembled from overlapping sections tied and pegged together with scarf joints, keyed tenons, and male-female joinery. These techniques distribute bending stresses across overlaps and pegs rather than depending on a single unbroken log. Wooden dowels driven through mating timbers, lashings of cordage, and well-fitted sockets could bind sections into a coherent keel structure. How might the builders have raised and aligned such a backbone? Likely they assembled keel sections on the ground, secured them with temporary bracing, and used earthen ramps and capstan-like turns of rope to position the growing spine. Heavy guide ropes anchored to large posts or rock clefts would control movement and prevent catastrophic twisting. Plumb lines and siding poles, simple but reliable instruments, helped ensure straightness. The goal of these measures was not cosmetic perfection, but the precise distribution of loads once the hull would float and rock. A poorly aligned backbone invites torsion, and torsion is structural fatigue. From that backbone arose the ribs, curved frame members that define the hull's cross-section. The ark's ribs may have been carved from naturally curved trunks when available, or from joined and braced timbers shaped to a curve. In some ancient vessels, ribs were steam-bent. On a pre-flood ark, builders might have relied on shaping and pegging multiple shorter pieces into laminated curves. Ribs would be set at regular intervals and temporarily supported with guide ropes and external scaffolding as they were raised. Carpenters used wedges and shims to fine-tune curvature. Plumb lines and templates ensured symmetry on either side of the central keel. The work of framing required acute attention to alignment. If ribs were set unevenly, the hull would twist, creating points of concentrated stress. The ark's scale intensifies this risk. Small errors multiplied along 137 meters can produce catastrophic misfits at the bow and stern. For this reason, builders likely employed repeated measurements from fixed points on the keel and employed templates, large wooden frames, breathed on by master carpenters whose eye for curvature set the rhythm for the entire hull. With the skeleton rising, attention turned to creating a continuous skin and making it watertight. The biblical text names bitumen, and that is precisely where ancient engineering meets the natural world. Bitumen was a known material in the ancient Near East, naturally occurring tar or pitch accessible from seepage pits or sedimentary deposits. Processing it into a usable sealant required heat and labor. The forgotten builders likely boiled bitumen in large cauldrons, mixed it with fillers such as plant fibers or animal hair to form a mastic, and applied it in successive coats. Application would have been methodical. The first layer seals visible gaps. Subsequent layers embed fibers and produce a thick, cohesive skin. Inside seams between planks were likely recessed to accept filler, yarn, wool, or shredded fiber, and then coated with pitch to form a caulking joint. Outside, multiple coats of bitumen would be applied and worked into plank seams, forming an outer envelope that resisted water penetration. All of this required patience, slow curing, careful heating, and repeated inspections. Such sealing practices are plausible reconstructions, informed by ancient shipbuilding across many cultures, but they remain reconstructions, sensible and possible, not definitive proof of the exact method Noah used. Making the ark livable was an altogether different engineering problem. The ark was not one great open hold, but a system of partitions, kenote or kenningen across 3 decks, designed for load distribution, animal safety, and practical logistics. Imagine the cross-section, 3 distinct levels, each divided into pens and storage rooms, stairways or ladders linking the decks, and narrow corridors for movement. Heavy animals and large stores would be kept along the center line near the keel to minimize rolling moments. Lighter or more agile species could be housed closer to the outer sides. All of this required patience, slow curing, careful heating, and repeated inspections. Such sealing practices are plausible reconstructions informed by ancient shipbuilding across many cultures, but they remain reconstructions, sensible and possible, not definitive proof of the exact method Noah used. Ventilation mattered. The text instructs a window a cubit from above, an explicit provision for light and air near the uppermost deck. That upper opening, plausibly a long ventilated slot, would allow stale air to escape, drawing in fresher air below. Inside, partitions would be arranged to promote air movement while keeping animals separated enough to prevent predation and disease. The builders might have used perforated partitions or open slats in pens to allow airflow while still restraining animals. Food storage overloaded the ark's logistical plan. Grain, beans, dried goods, and oil could be kept in sealed jars and baskets stacked in dry compartments. Hay and fodder required ventilated dry spaces to prevent mold. Water was stored in large clay jars or skins, replenished when necessary. The family would need working areas for preparing food, mending harnesses, and tending wounds. A systematic rotation of tasks, feeding shifts, cleaning, inventory management would have been essential to the ark's habitability over the long months of the flood. Waste management was grim but critical. Builders may have designed sloped floors and animal stalls leading to sealed tubs or channels that could be isolated and emptied. Where possible, waste might have been stored in containers to be disposed of later once the waters receded. The ark's interior was, in any plausible reconstruction, a constantly managed environment. Sawdust and straw used for bedding, routine cleaning to reduce disease, and careful attention to confinement and tethering. These details are informed by animal husbandry practices and practical common sense. They represent reasonable reconstructions rather than textual assertions. The side door was both a functional necessity and a structural challenge. Cutting a large opening into the hull creates a serious stress riser, a hole that weakens the framing unless reinforced. To compensate, builders would have heavily framed the door jamb with extra beams and diagonal bracing, tying the opening into the surrounding ribs and keel to distribute loads. A hinged or pivoting mechanism of metal would be anachronistic to assume. More likely, wooden pivots seated into mortise sockets, strong pegged pins, or a sliding threshold arrangement provided the movement needed. Protective shutters or removable planks could be secured from inside to conserve waterproofing. Structurally, heavier timbers and additional tying beams around the door would preserve hull integrity. And then the theological overlay. The text says plainly that after Noah and his household and the animals entered, the Lord shut the door. This is not an engineering act. It is the moment where divine sovereignty seals the human labor. Noah's craftsmanship prepared a vessel. God's hand ordained the timetable. The builder's work culminates in a threshold that becomes sacred. Practical reinforcement meets divine closure. The flood itself, described with the language of fountains of the deep and 40 days of rain, was not a gentle launch. The text notes the fountains of the deep breaking and associates this with subterranean forces releasing vast volumes of water. The ark's design, broad, box-like, with a relatively flat bottom, would, in theory, provide stability in turbulent seas, resisting capsizing. The 3 decks and high sides offered freeboard to ride waves. As the waters rose, the ark would lift, with guide ropes and ballast, stones or sandbags, used to adjust trim and to dampen excessive pitching. Inside the ark, life would have been a constant cycle of work and prayer. The creak of wood as the structure flexed and settled, the odor of wet fiber and bitumen, the low sounds of animals pacing and calling. These sensory realities filled the months. Feeding routines demanded discipline. Measured rations, successive feeding of species according to diet, cleaning of pens, and repairs to lashings and seals as the hull endured stress. Noah and his family were not mere passengers. They were crew and stewards tending a floating ark like a ship's crew tends a vessel through a long, threatening voyage. The text marks time with specific numbers: 40 days and nights of rain, and then a longer span while waters prevailed until 90 and 50 days more elapsed. The narrative notes 150 days of prevailing waters after the initial deluge. That chronology underlines the extended nature of the ordeal and the demands placed on both human resolve and the ark's engineering. Over months, maintenance would be a continuous task, monitoring bitumen seals, replacing worn lashings, and adjusting internal partitions as needed. These are plausible activities implied by the reality of an extended float and the nature of wooden craft. When the waters abated, the ark came to rest upon the mountains of Ararat. The image is at once geological and theological. The vessel settles on high ground, marking a transition from judgment to new beginnings. Noah's first acts on dry land are liturgical as much as practical: an altar erected, offerings made. This altar and the subsequent promise introduce the covenantal dimension: God's pledge of mercy sealed with a sign, the rainbow. The dove episodes are practical tests and powerful signs. First, a release and an immediate return. Later, a dove bringing back an olive leaf, the small but unmistakable evidence of renewed plant life. The narrative's precise symbol, a dove with an olive leaf, serves as both a literal indicator of habitability and a theological token pointing to restoration. Throughout this story, the human dimension is constant. Noah and his family working under ridicule before the flood, the surrounding community of onlookers and mockers who could not imagine such a vessel or the coming judgment. Obedience in the face of scorn is one of the narrative's moral centers. Yet, alongside that moral force runs a quieter theme: the dignity of human craft when aligned with divine command. The builders, Noah and those who helped, the unnamed hands and eyes, bear a kind of worship in their labor. Their measurements, their joints, their patient application of bitumen are acts of fidelity. They are forgotten builders, not because their work was insignificant, but because history remembers the ship and the covenant more than the long hours of sawing and pegging that made it seaworthy. It is important to keep perspective. Where the text is silent, we make reasoned inferences. Scholars suggest techniques familiar to ancient carpenters and shipwrights: scarfed beams, pegged joints, caulked seams, and these provide a coherent picture of how the ark could have been made functional. None of this should be presented as archaeological proof that a specific joint type or hinge was used. Instead, these reconstructions show the engineering plausibility that links the biblical description to known ancient practices. As the story closes, the final scene is quiet and laden with meaning. The ark rests, Noah steps onto new ground and builds an altar. God speaks a promise and sets a sign, no longer a vessel specification, but a covenant across the sky. The rainbow becomes a public marker of God's mercy, the solemn counterpart to the earlier command and the human obedience that implemented it. What then is the secret of the forgotten builders? It is simple and profound: human ingenuity that answers divine instruction with disciplined craft. The ark's successful function relied on practical skill: site preparation to mitigate wet ground, felling and transporting large timbers by rollers and ropes, joining shorter timbers into continuous structural members with overlaps and pegs, framing ribs and maintaining alignment with plumb lines, sealing seams with bitumen applied in controlled layers, and converting interior space into a managed environment of compartments, ventilation, and stores. Each of these is a likely technique informed by known ancient methods. Each is also an expression of obedience, a willingness to act on God's instruction with care, patience, and technical competence. From a theological perspective, the ark bridges two truths. First, God's command gives shape to salvation. Second, human work, measured, practical, and somber, becomes the means through which that salvation is realized. The forgotten builders teach that faith and craft are not opposites. Faith supplies the mandate and the courage, craft supplies the means. If the ark invites further curiosity about what happened after it rested, if you want to trace the resettlement, the dispersal of animals, and the covenant's unfolding, there is a companion discussion that follows the post-flood narrative. That video explores the practicalities of coming ashore, tending to animals on land again, and the early planning of a renewed human community in a changed world. Finally, consider what this construction story implies for us. The ark's engineering is neither romanticized nor reduced to a how-to manual. It is a witness to disciplined obedience, an example where precise instructions met concrete skill. The forgotten builders remind us that faithful work has eternal echoes, measurable, tactile labor that participates in God's larger purposes. If this study has stirred your curiosity, please subscribe, like, and watch the companion video on the post-flood aftermath to continue the story. For now, hold this image: 137 meters of timber, shaped by human hands, sealed with bitumen, manned by a family in prayer and labor. The ark's secrets are not mysteries of secret magic, but the careful application of ancient craft, the handiwork of those who built in obedience, whose names history left unrecorded, but whose work carries forward the story of survival and covenant.